important thing. Let me show you one example from physics. This say this is your differential equation, second order differential equation. Please, other than physics or mathematics, whoever have not done any differential equation, please bear with me for 2 minutes. This is a very known second order differential equation. Basically, dy is a variable, x is another variable, independent variable, and you are defining dy dx is rate of change of y with respect to x, and the d2y dx square is the rate of change of y with respect to x. That's it. And this is a very famous differential equation. We'll call it damped harmonic motion. So we want to solve this in our with Python. So what we do is that in Python, but we will know even if we have not done, the Python actually can solve only first order differential equation. So there's no problem. We can split it in 2 parts. We write dy dx equal to z, another variable, and then we write dz dx equal to minus lambda z minus k into y. So that is the thing. So you have to solve this 2 first order differential equations. Done. Okay, let me write it first. Suppose I create a function, say f, and I write in the function I give actually 2 variables. I give some, say, u, it will be clear, and x, and colon. U is this name can be given anything. Okay, you can give any name. And if I now write y comma z equal to u, that means basically if u has something which has 2 parts, so 2 parts, the first part goes in y and the second part goes in z. That means we need to address 2 variables now. Z, dependent variable, and y is another dependent variable, and x is independent variable. Everything changes with x, right? So I write y comma z is equal to u. This is the famous unpacking. Two things you write on left side, and basically u, it has 2 parts, so it will be part by part will be gone, will be going there. Okay, now I write return. I have to write a return, and then I write like a list of 2 things. One is I have to write this. One is z, and another is this, right? So I have to write, say, minus z, the first on the right side on the first equation, and there's minus lambda into z. Lambda, let me take lambda is, say, 1.5, some value. I don't vary here, and z, and then minus, say, k, and there was a k, right? There was a k here, and I give it, say, k here, say, k into y. So I return this. So function is defined. I go to another shell. I can write in one shell, no problem. But just for fun, I write x. I have to create another shell, right? So x equal to here np dot linspace. Now I have to this basically I will use a module which is in SciPy. So anyway, I have to integrate this differential equation from x value from certain point to another point. So I will actually integrate over, say, 0 to, say, 10, and I will create 1000 points. You can give comma rate step equal to true to see what is the return step size is here, but you need not see it here. I create 1000 points between 0 to 110. That means x value begins from 0, ends at 10, and 1000 points in between x. So these are the, you can think of that this first point is the initial value of x, right? Okay, and now you can give u. So you have to give initial value of, it's an initial value problem actually. Whoever have done differential equations, they know it very well. There's nothing to emphasize. And I can give, say, 0, 1. That means the u equal to, basically inside u, you have y and z. That means initial value of y is 0, and initial value of z is 1, right? So this is that. And now you will use OD int. Okay, I can write now. Oh, sorry. I can write, I could write here from, it's better to write above. I can write anywhere. From SciPy. SciPy is a package. Inside that there is an integrate module, import OD.
Shouldn't you want divide it equal to this divide tx? Shouldn't that be plus z?
Yes. Sure. Thank you. Yeah.
So many comments that come to that extent.
Okay. Because I cannot see the comments, so you manage, please. Okay, so u is 0, 1, and so the initial value of y is 0, initial value of z is 1. So that's it. So initial values are given. Now see this OD int function. OD int is ordinary differential equation. INT is for integration. So this this function actually integrates the one-dimensional differential equations. That's it. So these are we have basically two one-dimensional differential equations, and we don't have to write any explicit algorithm. My life is very simple. And if I write something, say I write solution, SOL. Solution is OD int, and you can type help. Inside that you can write OD int to check how OD int takes things. So it will take first the name of the function, then the dependent variable. Here are two dependent variables, y and z, but they are packed. This is packing, right? This is packing, and this is unpacking. So they are packed under the name of u. So you give u, basically two dependent variables, and then you have to give the set of the list or array of independent variables x. That's it. For any one-dimensional, it is two-dimensional. That's why we have this packing, unpacking business is there. Otherwise, for one-dimensional equation, it is nothing. You don't have to pack, unpack. Just one single y and x, right? So this solution is ready. Let's see. I mean, now I first run first and then run first. What is there? Oh, OD int and FUX.
Value of k is not defined, perhaps.
No, okay. Oh, sorry. I wanted to give some specific value 4, because otherwise I want to avoid this all jhamelas. Okay, thank you. Okay, right? Okay, done. Let's see what is sol. For whoever are seeing for the first time, sol. Let's print salt. So salt is it's a two-dimensional array. You can now recognize this is a NumPy array. Seeing the two square brackets, you can understand this is a two-dimensional array. And if you read the manual of this OD int, you will see the first column, not this, the first column. This first column will give you the y, and the second column will give you the z. Now you know how you can slice this thing. First, separate out this first column and second column, means 0th column and the first column. So I write, say, y equal to sol, this is my solution, and then you write colon, then comma, then 0. You see this first colon means you can put two colons here, but you can write one colon itself. This first part is for the rows, all the rows. That means you take all the rows, and the comma, this is the 0th column. So you take this 0th column. You can now check z. Z is sol, give colon, comma 1, right? So that way you select out separate the columns, because now you want to see the plot. Now come to matplotlib. Okay, import. Now the plotting things I have not imported. It's up to you how you design your program, but it's okay. Of course it was done, but still I do matplotlib.pyplot as plt, and then you see plt.plot, and then you write x comma y, and then you run. Matplotlib, it was done actually, but still I did it just for the sake of and then matplotlib. I'm doing so many mistakes. Sorry. So the plot is done. I can now go here to reduce the size, so I can show you this is the plot. And you now add plt dot axh line, and you see run, and the x line is there. You can now plot with, say, y versus z. That will be basically phase plot. So it will be the phase plot, or then you write it, comment it, then comment it. So this will be the phase plot and everything. So the things are at your hand, whatever you want to do. Okay, so now we go over to next next thing, where we will actually create a file. We'll create a file, data file, and then plot. Okay, then plot. So let's see what I did is something. Let's see. I've not created the file. Let me create. I could have created the file. Let me notepad. Let me write notepad, or let me notepad. With notepad I can create, or in fact I can do it on with the NumPy interpreter. Okay, so the data are basically, you can write some data, say for 1, say 2, 3, say 5, 6, 8, then 9, 11, something, 10, and 15, and some things. So suppose this is your data, and then you write created data and save as, say it is on download. I create. Okay, so write it test dot. I always write test dot dat. It's a text file, text file, but always write to show that it's a data file, and you create it in downloads. Okay. So this. So I created a file. Now what I'll do is that I'll write here plot from a file, and I go here, markdown, run. Okay, now I create data, write a data, and now I will read the data. So data will be read by, say in NumPy there is a this function, good function, is called load text. You can read without that also, but it is, I think, easier since we know NumPy, and we can go there. We we go there and check where is the function, this downloads, and the test dot, see the path here. The path is this path. Copy here, go right here, paste here, colon, and downloads under that. So there is a test.dat. Okay, so now you run this. Okay, I think it will take these symbols here because it will take as a escape character these things. So give these symbols. And this is something very something to note. Okay, now you run this. Yeah, so it is saying nothing means data is actually loaded in your here. Let's see what is data. Data is this data. You see, it has, since you are coming through NumPy, that means automatically you have actually converted this as a 2D NumPy array. That's it. It's like a matrix. Okay. So you can actually type that. You can type the data and check. So it is a NumPy array. You can actually, the first time you are doing it, for example, you got some data file from somewhere in the net, you downloaded these with this, downloaded, or you just direct from the net also you can do it. You don't have to download even. I will show you. So you use this load LOAD, you use this LOAD load text, this function, and you can now the data is in your NumPy array. So that's I always will emphasize again and again that NumPy array is, we all are emphasizing the NumPy array is very important for all of us. Okay, there is no escape. Okay, Okay. So you can also check np dot shape of data or data dot shape. Also, you can do that. You can also write data dot shape. Data is already numpy array. You can check the shape of data. Suppose this is small data, all few data, fake data, but for a real data, you see this is a huge file. So you do not have to, you do not understand what is the size of the data, shape of the data, etc., etc. You can also always check that it is a 5x2 array. That means 5 rows and 2 columns. That's it. Now you can plot that. So now again you can that you have since you have actually loaded the data on your namespace, you can write x equal to data, then colon, comma, 0. This is your, because it's two-dimensional, so the first column goes to this x, and the as usual, as before, and the data, the second column goes to 1, right? 6y, and then you can write also, you can write also x and y. No, you can write x to check what it is. See the array. You can also check y, what is the array. See the all the data that we have given. This is the x, this is the y. So you will have no problem or no confusion. Okay, now I plot plt dot plot, and then x comma y comma whatever, something, colon, in comma with red, whatever. So you do that. You do this file, okay, and you check that. Okay, now you can actually write a lot more things here. Let me write here. So we have created plot. Okay, let me plot grid also. So it will create grid that we have seen. Why it does not? It should show both sides, but I don't know what else it is. I'll check. Okay, let me will check why it is not taken the grid on both sides. Okay, anyway, but we'll check. Something's problem. Maybe we'll refresh and we'll see. Okay, another important thing is that the x-axis, the data are plotted here, say 0 to 10. Okay, but I want to plot, say, for example, 2 to 8. So I can limit the x-axis. So we have another function, plt.xlim. So I can give it some 2 to, say, 8, and the y-axis. So this, let's see. Okay. Oh, what is? Oh, it is not. Why it is not writing this? Let me check it again. Why? Oh, some conflict was there. Okay. So, and the y-axis is, for example, you don't need to show all this. So y-axis is confined between this and this. So I can plot 2 to 10. So I can write plt dot ylim 2 to 10. So I can run that. So this way I can limit. So y-axis is from 2 to 10 and x-axis from 2 to 8. So I can use that. So I can use, I earlier used x level, y level. So I can write plot x level, and inside that, actually, I can now, like LaTeX, I can use LaTeX curve. Whoever have not used LaTeX, don't worry, because I will just tell you how you write. Suppose you want to write, say, for example, say in dollar, you have to write, of course, you have to write rho, R-H-O. It looks like, looks like P, right? Rho, for example. Alpha, beta, gamma. Alpha is alpha, beta is beta, or beta something, or say beta, whatever. Say beta, B-E-T-A. And you have to write this, in this, and you have to put inside this string, one string, okay, two string, two, why it is, okay, one is enough, okay, anyway, one is enough, why it is not, I mean, you can put 1, 2, whatever, okay, and, but you have to put here a R, remember this, put to R is for raw string. What it is, you can meanwhile ask Anando, he is there, you can help you, or otherwise forget now, you can explore yourself. Okay, x level is here. So these beta, I want to write beta on the x-axis, and also say I can size, just a demo, say size 18, and I can want to put plt dot y label, and I can put another arrow string inside that. I want to say put beta, theta, you know, all these Greek symbols, and these, it has to be this. So remember, the name comes with slash. That refers to the dictionary. That refers to the library where it is, and it has to put inside these $2, and then inside just 2 strings. And also, before you write R, that don't forget to write R here. And that's it. These are all familiar with people who do LaTeX, in typing in LaTeX, right? So this is size. Size is say 18, 20, say 20. Okay. So now you write this. Size equal to. Oh, I missed this comma. Okay. Right. Size equal to y label r y label plt dot y. Oh, label. I spelling mistake. So again, x label are these things. These x label plt dot y label, or it is PLT.
You closed the string wrongly. The y level string is closed with double.
Yes. I mean, double is also okay, but I was not liking the double. We could put 2 side double. Thank you. Okay. So now this is this. So you see the beta is here. And the theta is here. Theta versus beta, whatever it is. So you can the same method.
Would you please reduce the size? We can't see the whole screen.
Okay. No, I was just showing the beta and theta. That's why. Now I will reduce the size, just to show. Now it's okay. Now it's okay. I think okay. Okay. So this is what it is. I mean, the thing is that I can now write all these things anywhere. On this level, X level, on the title, on the legend level. So these Greek symbols, or some mathematical, say something to the power something into exponential, something into sine of something, all these mathematical functions styles, we can write all these all these libraries are available. You can see inside this matplotlib, it is there. You can Google search, and you can write these symbols anywhere inside this graph, top, level, anywhere. Okay, so that was I wanted to show. And also you can also plot arrow inside. You can indicate that this is the value or something like that. So you can plot plt dot arrow. Lot of the things. I mean, it's unnecessary to show all those things, but still you can. You yourself can explore. But it is. I have time. That's why I'm showing you all those things. Okay. Now you can write, say, for example, some arrow. So in arrow, you can give some certain, say 4, say 7. I can say write 4, 7 coordinate, and then I can write some certain, say something 9, 8, something like that. I can write some 9, 8 coordinate, and I can write length. This is the arrow is the function. So length underscore includes this is a keyword argument. You understand, underscore head. So arrow sometimes comes without head. So sorry. I have to write this is equal to true. By default, it doesn't give you the head. So it will draw the head, and you can also fit head width equal to some 0.3, and you can also write something somewhere. Okay, now see, let's check. Oh, no. You have to integrate with everything. You have to write everything and everything. Okay, first you can copy this here, and along with that, then I have to do along with them. I can paste and I can run. Oh, the arrow is so big, and it goes from here to here. I'm gonna. You can reduce it anyway. So you can like, it is no. This is the size. This is the size. It goes. Actually, I'm wrong. The 7 is the size. 7 is the size. So this is the say. I write it. So it starts from x coordinate is this, y coordinate is this, then it is dx, and it should be dy. That's what I think so. We have to check it. Say 1.2 and say 1. Say you can explore it yourself. Oh, it is 2. It's actually somewhere goes. Anyway, you can control it. You can check it yourself, right? You can do it. Something say -9. Say check it. No, it is going out of the panel anyway. So forget that. You can actually do that yourself. You just try at home. Since at the moment it will take a lot of time to manipulate. I have to check it again. I have to see the manual. I forget everything. I have to see the manual of
from xy to x plus dx, y plus dy. The first.
Oh, see, first two are xy, right?
First two are xy. The next two are.
Oh, okay. Then it's okay. The first two are xy means right. That should be. So I suppose I wanted to plot say 4, 6 positions. Okay. Thank you. 4, 6, and then I'll give you the delta x, delta y, right? So I'll go up. So I give delta x. Say I give delta x means I'll say right 2 size, and then I give say 1.2. Right. Okay. It doesn't matter. So let's see. Yes, xy delta x delta y. This is it. So you want to point out here, point towards here, you have to adjust. You just see where, suppose I want to point arrow from here to here to show this data, write something legend, some label. You can give it some label also. You can give some label and so on. So you can also write plt.text that writes text inside these things. So write text means you here. So for example, say 8. This is 6 and this is 8 coordinate. So you write say text means you write say 6 and 8. At this position, you write some text. What is the text? Say important value. You write important value, and then you write also adjust the size also. Size equal to say 18. So you run this 6, 8. So sorry 6, 8 plt dot text. It will be text. It will be text. So the important value is written here. You can write something. So suppose this way you can decorate your graph. Okay. Any problem? So this is how you can write your graphs. Okay. So now you run this. Okay. Now I will talk of multiple plots. Okay. Multiple plots. I'm not even halfway, so I have to do first run. So multiple plots. Okay, as Hoimantudi was asking, so we'll see that x equal to suppose np dot linspace. Suppose these things are already imported. X is this, and then you see y1. Y1 is c np dot sine of x and sine of x. Then say another I want to plot with the same graph in y2 equal to np dot say sine say x star x square inside. Okay, and say I want to plot plt dot plot. I want to say x comma y1 comma x comma y2. That's it. If you do this, this is a function you are plotting y1, and this is a function you are plotting y2, and you can actually plot is run, and you see in the same graph. It is not. Oh, sorry. Y2. Lots of mistakes today. So see, you see, two plots are in the same figure. If we call this canvas as a figure, and the one set of line is one plot, that way we nomenclature, we give the names. So two plots in the same figure. Now we can also write. We can also write plt.plot for the same thing. I can also say, I can take this is the first set of plots, x comma y1. I can give the colors of one. I can give it a green in one color, and then see the keyword arguments will follow after each graph. And just to show you one thing, and say red one thing. So one will be green, another will be red. So it will be with green and red. So you manipulate both with the same set of keywords. I mean the similar kind of keywords. Well, also you now write, for example, like suppose you write x equal to np dot linspace. Now say you write np dot pi and 100. So you create minus pi to pi plus pi, 100 numbers, and you write, say, for loop for, say, n in range, say 1, 4, say, for example. Right? So I'm writing the just bona fide Python program actually, but I want to do plot. See, you can always write little bit of Python program, so to make your things as the way you want, an x. So that means inside that n will be the range from will be so range will be from 1 to 3. The n value will be 1 to 3. So first it will plot plt.plot x versus this sine 1x, then it will plot sine 2x and 3x and so on. So that's it. And I can write, say, LW equal to 3, for example, etc. And let me check first, run this. So that's it. You write. So you see you have plotted three similar, the three functions of the same genre. Since you can do a for loop, you do it for loop. For data manipulation also, you can write for loops whenever you want. You could do list comprehension also. This is your task, how you will do the way Arunahoda showed. These two things you could write in a list comprehension way, but you can do that on yourself, and your code will be nicely looking, etc., etc. You can also say give the plot the legend, and also since the three figures are there, we have to give three legends. So for example, I give R and the inverted comma and then the dollar, and then they say I call it a new. New is a Greek symbol. So new equal to, say, for example, I give 1. So the dollar completes, then inverted comma, etc., etc. So I will copy this. I'll copy this, and I do not remember control keys. That's why this is a problem. I have to copy and manually and things. Okay, so these things. If you do that, so now see, so the legend is coming. So inside the legend, these things you are leveling. You have put the levels, and the levels are in a form of list. It's a list of levels, and it is putting you automatically here, and you know how to put it some best place. Suppose here or here or here or here. So you can do that. Okay. Now two figures side by side. So multiple earlier it was multiple plots in the same figure. Now we have multiple figures, multiple FIGURES, multiple figures, and you have this, you have code, you have markdown, run, okay, multiple figures. Say suppose x equal to np dot arrange, and then you say 0, 2 star np dot pi, and then 0.01. You know what it is, and then you say write plt dot. Since two figures, I have to write. Earlier, I need not always write this plt dot figure because I was plotting only one figure, but I now will plot two figures. Plt dot figure, and I can write is the one figure number 1, and then I can write plt dot plot, and inside that I write xpx comma np dot dot yeah, sine, and in bracket x, and then I will create another figure, and another figure, copy. I create another figure, and I name it say 2, number 1, number 2, and you can call it say sine, say what about cos, or let's say cos. Here very famous trigonometric functions. So this is figure 1, this is figure 2, and I do the same thing. Let's see what. So one figure and then another figure, and yeah, so one figure, another figure. It's not side by side, but it is on one top of the other. But in suppose you are doing it on interpreter, it can show you side by side. It depends on the interpreter you are working with. So okay, so now I do one thing. I now change here. I now write 2, and I now write 1. You see the sine curve was here and the cosine curve was here, right? And now I write figure 2. That means number 2 will be first, and the first number 1 will be the second. When I run, you see, no, oh, it should go, no, it should be, actually it should go, yeah, or otherwise I have to write the whole thing. I'll be change the whole thing. Anyway, I think it is. Let's see. But the numbers can be altered actually. I mean, I don't know why it is not coming, but you can try on it on this shell. Okay, so you can try this part. Okay, I'm not wasting time on this. Now the most important part, one of the most important part is subplots. Suppose you are doing some research, you are presenting your data to some people or some research paper, and you want to actually plot several figures, to incorporate several figures, not plots, several figures together, like these two figures side by side. Now you can control, you can now plot 4, 5, 6 figures, one other side of the other, and etc., one inside the other, etc. All everything you can do. That is the by another function called subplot. Okay, so now you write subplots. So this is subplots, and this is, and this is run. So this is subplots. Okay, subplots. First thing is that this area, the figure canvas, you can separate it in some portions. Like unfortunately I have not unfortunately I cannot draw. Can I draw here? Oh, sorry. Can I draw here blank home new slide, and you can draw here. Suppose you draw here, oh, box. I can draw a box. Okay. I can draw a box. So this is your area. Here you want to plot, and now take a line. I divide this. Oh, line cannot be seen. I have to make it transparent to make it. And this you can draw this, right? Oh, you have to take it again. You have to take it color. Where is the color? Gone. Anyway, where is the color? Oh, color gone. So this is suppose this is your canvas, and the canvas you are separating into 4 parts. For example, this is number 1 quadrant. Second, it is 1, 2, 3, 4. So this is I wanted to tell. Okay. So in subplots, you write plt dot subplot, and the total position. In this case, the total area I am dividing into 2 by 2 matrix, right? This is 2 by 2, 2 by 2 matrix, right? So you have to give 2, 2, either 2, 2 or 2, 2. And then I want to refer the position quadrant numbers, 1. So I want to draw the first graph here, okay? And then plt dot say some function, and this let's say x, some x, x equal to say something np dot lin space 1, 10 and comma say 1000. Okay, so plt dot plot, and then inside that you write x and say np dot sign and say x start 2. This is the first plot. So this is the first subplot. Then you copy. Copy here, copy 4 1. I need 4 ones. Yeah. So 2 to 1, then it is 2 to 2. Let's say it is exponential. So it is exponential, exp, another function. Say it is say exponential, say something exponential, say something x square or something, minus x square or something, and say it is something only x square, say. Okay. Now it is 2 2, then it is 2 3, and it is 2 4. Done. Your the thing creation is complete. Okay. So 1 2 3 4 parts, 4 plots, subplots, and you see. You can show is this is your subplot. So you can actually set the canvas size, etc., by fig size, etc., separate them out, control these YZ levels so that it does not like this foolish way 1000, 2000, etc., and you can actually control all these things. So these are all 4 things, 4 parts. You'll check the presentation whenever you want to do. Okay. So next part. I will to show some statistical plot. So now it will be plot. Please tell me if I want to give some interval or whether I can continue. Convener. Plot statistics. Convener has slept. Okay. Plot statistics. So I can write
Yes, I am here, and I
Sure.
think you can continue.
We can continue. Okay. Because if you want to give a tea break, we can give it. Okay. So np dot, or can tell me that it is we can stop. Okay. Arrange. Because of course there are many more fantastic things are there that will be kind of visually pleasing, that will come later. I'm saving for the last session. But anyway, np dot range, and then y equal to x star 2, and then you write. So you create the numbers. You know this, no? 0 to 9. You have created numbers, and you take the y equal to x square. By this time you have been seeing these things again and again and again. All these arrange and lean space functions will not leave you anywhere. So this is error bar. I want to show you the statistical error bar. You have measured something, some data. Of course, this is a fake data. All these are fake data. You have your original data. You can give the error bars. So error bars, you know how to calculate, young students. So you see, you statistical measure, you take every value, one value again and again and again, then take standard deviation, then divide by square root of the number of the samplings, n, etc., etc. These are the error bars. So often you see the plots where the see scientific in the communications, the data will be some bar will go up and down, one bar will be go side by side. That's are the error bars. Size of this error bars is important. Okay, so these you write x comma y, and then you can write x error equal to 0.4 and see y error equal to 0.3, and the color equal to say red. You can color equal to say red. Okay, so the error bar, actually you have to give x data, y data, and then x error and y error, nothing else. Of course, it is same for every measurement. That cannot happen, but it's a fake data. So that's why I'm doing. So this is the error bar, run. Okay, so you see the error bars, but the y error bar is not showing. Your error bar has to be given more, because the y axis, the y values are, it's a huge values. So compared to that, the y error bar is small here. It should not happen. So I give it 3 instead. You see the error bars of, this is the x error bar, this is the y error bar. Can you see that? Okay. But it is, of course, you can understand these x error and y error are the same for everything. This cannot happen. So in practice, if you have the data, x axis, you see in your file, say x column, then y column, then another column will be for x error, then another column will be for y error. For each individual value, taken the recorded meticulously. So the here you see the for every point, if you want to give different error bars, of course you understand the technology of Python. You have to give a list here or an array of errors. You have to give a list or array of errors. That's it. That's it. So it will take care. So the corresponding x value, the 0th value of x will correspond to 0th value of the x error, and so on. So that way you understand the technology of Python, how it works. The other day, my one good friend was talking to me and was saying he's for the first time he's doing Python, and after some sessions, he was telling me that the Python is some problem because you have to remember so many things. I said no. Of course, my other 2 friends here, speakers, they will also agree. You do not have to remember anything at all. You remember some cardinal points, because from the since the first day we were showing so many things, because so many modules, so many methods. But you see there are some similarity, there are some links, and there's some same kinds of things apply. The methods are applied for, say, some methods applied for say list will be applied for string or tuple or so on, and you see how to manage, how to deal with the functions and classes and everything. So that's why I say you do not remember anything. Just do not remember anything.
All you need to know is how to Google.
How to Google. And another 2 functions, dir and help. That will really help wherever. Even there is no internet. I said the first day I told you a story of a man who was in jail, etc., etc., and people even on space where there is no internet can also do computation Python, because if you carry your laptop, or everything is there. You can see every possible help. You can check and see, and if you know, Arunabudha told you or demonstrated how to write a function, what are keywords, how to check what is the how a function is made, etc., etc. Then you can know how to, like looking at a good book or dictionary, where to see, what to see, etc. Like in a function, the manual, you can know, where you have to see, how you do, seeing the examples and etc., etc. what are the keywords, some basic things are important to know. Anyway, so these are the error bars.
Abhijit,
Yeah.
a break at this stage depends on how much you have covered and how much you need more.
I have covered 65.5%.
Then I think we should have a
Abhijit,
break.
it's a very
10 minutes.
relevant question. How are you so sure about your fraction? How are you measuring it?
Can anybody ask? I mean, when some people say, see, it is a possibility, 90% chance Bisti Hor, does anybody ask? So that's why I gave a precise answer. I knew the convener will be kind enough to not to ask me this, but you are notorious.
No, I think you need
we
a.
can give a
I
break. I
think
think we can give a
you
break.
need a break and please have a cup of tea or coffee.
Okay. We'll start from 5. Sharp at 5.
Okay.
In the meantime, I just want to make a comment that the aim of this workshop, I mean, after this workshop, it is not necessary that you remember everything that has been taught here. It is kind of awareness thing. When you are writing your own program, just be aware that something of this kind was shown and just Google it out. I mean, it's very easy. To make you aware of the possibilities and the potential is the aim of this. Just know that these things can be done. I mean, now
You have to
you do it
essentially
yourself.
learn how to read the documentation, and that after you read a few, you will be able to pick out yourself what every term means there. That's all, because nobody, I'm pretty sure, I don't know about the other two speakers, I definitely don't remember all these commands on everything. If neither, I just Google it out.
No, it is not necessary. I mean, the
You just
important
type a
training
few
is to
lines and
understand
Google it.
by Googling or help,
Please,
seeking the help.
sirs. Dear
Yeah.
sirs, please
Vimontidi.
enlist the cardinal points.
I mean,
the most cardinal point I would say is how to name variables, how to use assignments, how to write functions, and the whole idea about indentation. For loop, if condition, if
Please make a list.
Bas,
Please make a
that's it.
list.
There's nothing more. That's it.
Then
Everything else
there
you
are
can Google.
six points.
Yeah. Just say there are 6 cardinal points. So that's it. Cardinal
6
direction.
cardinal points.
Look, basically, if you know how to write a loop and how to use assignment, then you can program in any language. And the rest are just things you can pick up on the way. And the only way to actually even remember part of it is to do it yourself. You keep on writing a few programs, make errors, read what is cardinally important is reading the error messages, not ignoring them. And from the error messages, trying to figure out exactly what is going wrong. So that's the only way to learn how to program. Write a program. If you don't make an error, you don't learn anything. If you make an error, from the error, you can actually figure out exactly what's going on.
Okay.
You have to write programs. That's the only way. This is not a spectator sport. You cannot learn that just by listening to somebody.
Thank you.
If anybody has any question, then please ask, and experts are here to answer these questions.
Okay, in my graph, the last one you showed, I am only getting the x-axis error bar and not the other one.
No, that might be because your y-axis error bar is too small. Just check whether the scale. That's why Abhijit had to change the y-axis error.
Okay.
Compared to the scale, it may have been too small.
Okay. Thank you.
There's a question, can matplotlib be said equivalent to QTI plot? Not really. The real advantage of matplotlib really is that you can actually use the full power of the Python programming language while using it. Which, by the way, you can also, for example, GNUplot Python has a GNUplot module as well. So the whole point is you can write a program while writing the program. You can modify things, you can recalculate stuff, use everything that a programming language allows you to do, use that to modify your program, even in real time. Your plot may be animated. They keep on changing with time. Or you may make adjustments to your book. So the whole point of using Matplotlib as opposed to standalone plotting software, the standalone plotting software requires you to have the data or whatever. It doesn't really, it's not really true in the sense that GNUplot, for example, is also a full-fledged programming language if you want to use it that way. But it's not really meant to be that. It's not designed to be that. It doesn't really do a very good job of it. Whereas Matplotlib actually leaves all the computing part to Python. So you can use the full power of Python and then use it to plot. The whole point is this is just a Python module. It's a part of Python to be used within a Python program. You can use it almost as a standalone agency, but that's hardly major usage or even its major plus point. It can do most things that most of the programming language other softwares can do. Can Matplotlib produce 3D plots? Yes, I'm pretty sure Vijay is going to talk about that. Slightly more complicated, but well, of course, it has to be in a 3D plot. It can do that. And by the way, there are many things you can configure about these graphs and their appearance and so on. Impossible to really go through all of them in a lecture, and is also useless because nobody will remember all that. It's best that you take a look at the documentation. Documentation is pretty extensive. It tells you everything. Is Matplotlib in some sense then superior to GNUplot to GNUplot in terms of scope? Matplotlib isn't. It's really not Matplotlib which is superior or inferior. It's basically the fact that you have a full-fledged programming language backing it up. The Python program in which you put in Matplotlib that makes it more powerful. And by the way, you also have a GNUplot module in Python that can also be used. Although I would say the GNUplot module in Python is not as well developed as the Matplotlib module. By the way, the Matplotlib module is essentially sort of modeled on MATLAB's plotting capabilities. So whatever the expensive program MATLAB can do for you in terms of plotting, Matplotlib essentially can do almost, well, not almost, it can do all of it. Okay. What makes it more powerful or less powerful is not that it is intrinsically more or less powerful. Just that you have a programming language which you can use it directly in. When to choose a list and when to choose a string? Is that really a question, or when to choose a list and when to choose an array? There's no way. Lists and strings are so different that you can never confuse it. Right? List is just a list of objects. For a particular data, you have specific standard deviation, not really. Depends. Say maybe for each x value you have measured y 5 times. So each y may have entirely different standard deviations for every point. In fact, in experiments that exact. You're talking about the standard deviation for the whole data set, but usually for every x you repeat measurement several times, so you get different standard deviations for different x's. Can we use Matplot to simulate? Yeah. Matplotlib, you mean. You can't use Matplotlib to simulate. You can use Python to do the simulation. You can do Matplotlib to run the picture. So if you mean by simulation, you mean a moving picture of what's going on, you can do that using Matplotlib. The simulation, of course, is done by Python programming, not done by Matplotlib. And there was this question about, okay, this was strings and lists and arrays. Well, arrays are way more powerful than lists. So unless if you're planning to do anything very mathematically involved, that is a better. These are actually not really good for mathematical calculations. These are primarily useful for other things. Does Python also have a module for QTI, but I don't really know. I'm not aware. Might be, just look at it. It might be possible. May not have it because it's not necessary. After all, GNUPlot module was developed at a time when Matplotlib was not available. Who suggests some resource for simulation? There's plenty. Just look at Google, look at the net, and you will find plenty of, say, even just type Matplotlib animation, you will find many of them. In fact, by the way, I'm not sure whether you've seen the 2 movies I sent over last day, plotting fractals. They were by Matplotlib animations. They were Python plus Matplotlib. The calculation was Python, the picture was Matplotlib. I just took a screen capture of the video that was being produced. Okay, I think Abhijita is back, right?